Hello and namaste. Welcome to the second lecture of gas chromatography. Myself, Professor Andy Pupate. I am from Sudhakar Naik Institute of Pharmacy, Pusat. So, in the gas chromatography, in the first part, we have studied the basic theory part in gas chromatography. That theory is used in short notes as well as might be separate question is asked on to that part red theory plate theory. Okay, Van der Meter equation is another part that they can ask to you. Okay, so that is an important part that we have covered in gas chromatography 1, in which we have study about a retention time. Then we study about the retention volume, means from sampling to the tip of the peak that get forms is retention, whatever the time is there, and how much is the volume that require from sampling to peak formation. That is nothing but the volume. Okay, so we have covered that point. Then we study about that plate theory, which is an artificial theory in which n is equal to L by H, means height equal to theoretical plate. So n is nothing but that equation that we have taken. So we put up that value 60 TW whole square. So that value we have put up, and when we get the final formula, then that thing is an artificial theory we have studied in the case of plate theory, where we artificially arrange the number of discrete theoretical plates. Then we have studied about the rate theory. In the case of rate theory, also called as a Van der Meter equation, in which itself a rate means what, there is a speed means what, there is an velocity, there is an transfer of analytes, uh, there is a movement of an analyte that we have studied, means by the use of three different terms, uh, ED diffusion, longitudinal diffusion, resistance to mass change or transfer. So that is called as the equation A plus B upon U plus CU is the nothing but the velocity. Okay, and A is AD diffusion, B is longitudinal diffusion, and C is related to the mass. So we have covered with that part and put up that means in the case of this ED diffusion, there is an uh, generally takes place, there is a traveling the whatever. So we discuss on that particular part. uh, that theory part is very important because there is a migration of the analytes in, as I told you, in the case of longitudinal diffusion and eddy diffusion. Longitudinal diffusion means what, through which the which route they are traveling. uh, they are means for that there is a requirement of an adsorbent which are uniform, so they can travel through that one easily, they can create a path. And if they are not uniform, the path is very different or difficult, so they can't reach at the same time, means some analyte can reach, some analyte cannot reach. So that's why there is an peak bonding can takes place, can't get a proper peak. Same in longitudinal diffusion means what, when we keep it a sample at the center, then it travels from center to the periphery. At the center there is a higher concentration, but as it reached with the mobile phase with a particular velocity, then at the periphery it reach and we get the separate components. So that thing we have studied, and resistance about the mass transfer. So that 3 points we have discussed on that one, even by the use of the graph. So that whole parts is the gas chromatography 1. But now we are discussing about the gas chromatography 2. So in the case of this lecture, even we have discussed on the introductory part. Today also we discuss on introductory part. Then we study about basic principle of gas chromatography. Even we cover with the theory in the gas chromatography 1. So we are neglecting that point. Otherwise, principle, theory, instrumentation, application, derivation, advantage and disadvantage. This is the part of the gas chromatography. But in the case of this one, as we cover with the theory part, now we move towards the principle part. So in the today's lecture, we study about introduction, what is the principle, and then we start with the instrumentation part. So in the case of instrumentation, we have to study about the uh, whatever the kind of samples are there. For the it is an whatever the mobile phase is, this is the gas. So we have to study about the various kinds of gas are there which are using in the case of gas chromatography, and then we have to study about the injecting, and before that we have to adjust the flow of the gas. So that we have to study, and then we have to inject the sample into the carrier gas. And when we inject that sample into the carrier gas by the use of septum and hypodermic needle we are using, fine needle we are using to pass that sample. Okay, and then it reaches towards the uh, column. So what is the role of column is to done with the separation of the components. Okay, some are showing the more absorption, some are showing the lesser absorption, and on the basis of absorption it shows the separation of the components. So we move towards the lecture part. So as we have discussed, that is the objective part. So what is the objective? That we have discussed that to know the basic introduction and the principle of the gas chromatography, then to know the various kinds of the components uh, of instrumentation in the case of the gas chromatography. And then as I told to you, we have to study about the various kinds of the carrier gas. Then we have to inject the samples. So we have to study about the sample intake systems. And then it reaches toward the column. So where there is a separation of the components takes place. So we have to study about the columns, which kind of columns that are we are using. Might be there are the different kinds of column like open tubular column, subordinate open tubular column, pack columns. So might there are the different kinds of the columns that we are using in the case of this. And then there is a kind of detector. We have covered that part in the next lecture. So we have to also study about the various kinds of detector that we are using. Okay. So one by one we start with the first one, that is an introductory part. So in the case of introduction, this technique, so what is the role of the gas chromatography? Basically, it is used for to the separation of the component. We can take the mixture of the drug. That mixture of drug can be separated into the individual one. Okay, but the what kind of substance that we are preparing? So separation of thermally stable and volatile substance. Okay, so technique used for the separation of thermally stable and volatile substance. It is an simple and inexpensive method. That instrument is an expensive, but that technique where the separation takes place, rather than the HPLC, it is an easiest technique because we are using the gas. In the case of HPLC, we are using the solvent for the separation, or the mobile phase is used as a solvent, and that solvent are higher costly. Rather than that, in the case of GC, it is an inexpensive method. Okay, so as I told to you, as itself name indicate, it is an gas chromatography. So mobile phase is used. What is the mobile phase that we are using? Generally, it is nothing but the gas. And stationary phase is maybe solid or might be liquid. So it might be gas solid chromatography or gas liquid chromatography. So whenever the one word comes solid, then it is also called as an adsorption kind of chromatography. And when the second word comes liquid, then it is called as a partition type of chromatography. So we have to study, or this theory or the gas chromatography is related with adsorption chromatography as well as partition chromatography. Last year, GPAT question is asked, means in the year 2090, the 1920, the question is asked on gas chromatography. So same part the question is asked, and this one, gas chromatography, is widely used technique, and nowadays is most kind preferably type of chromatography where separation is takes place. So that is an introductory part of Even in the case of introductory, we can say that it is require very less amount of the sample for the separation. The technique is quick, uh, and we get result in quick succession of the time and so many parts in the case of the introduction. Okay, so now that is a part of the introduction. Now we move towards the basic principle. So in the case of the principle, so principle involved in gas chromatography is, as I told to you, where we use stationary phase as a solid or we are using the liquid. When we're saying that solid is there, then it is called as adsorption. And when we use the liquid is there, then it's prefer the partition. So here is the one word. First line is there. Principle involved in gas chromatography is adsorption. It is adsorption or partition, which depends on the stationary phase. Okay, so adsorption solid, partition liquid. It depends on the stationary phase might be solid or liquid. Okay, if stationary phase used in solid, अगर हमने stationary phase solid में use किया कर लिया है, so it is called as then gas solid chromatography. Okay, so it is called as the gas solid chromatography, and separation takes place by adsorption. सेपरेशन कैसे होता है इसके अंदर, एड्जॉर्प्शन के हिसाब से होता है. एंड इफ स्टेशनरी फेज यूज्ड इज लिक्विड, अगर आपने स्टेशनरी फेज लिक्विड यूज किया है, सो इट इज कॉल्ड एज द गैस लिक्विड क्रोमेटोग्राफी, एंड सेपरेशन टेक्स प्लेस बाय partition. So that one word, that three words comes together. Okay, I think you are getting that point. Gas solid chromatography, gas liquid chromatography. Mostly we prepare the gas solid chromatography because there is an adsorption text. If the adsorbent are solid, अगर आपके पास adsorbent जो है solid nature के हैं, then we prefer the where the components which is having. Okay, so mostly gas solid chromatography we are saying that one. Okay, so now in the case of adsorbent, that we are, so it's the adsorption type of chromatography. So as we are knowing that what is the adsorption, when we as we have studied in the case of column chromatography, हमने क्या किया था कि column chromatography में हमने already ये study किया है. Okay, if you want to be take this one, so हमने क्या किया है कि एक ऐसा here is one column, तो इसके अंदर हमने ऐसे adsorbent put up किए थे. Okay, so here is what we are put up the different adsorbents, and through which there is an traveling the whatever the analytes. Okay, so हमने इसके अंदर क्या किया है, ऐसे analytes हमने place किए, so that analytes might be travel from different paths. So हमने ये path create की थी analyte के लिए, तो इसके through ये pass हो रहे हैं. तो whenever the analyte get passed from this one, so analyte जब पास होते हैं, here is what this red color indicates the adsorbent, उसको हम बोलते हैं adsorbent. So what is the role of adsorbent? To adsorb towards themselves. वो क्या करते हैं, sample को खुद की तरफ adsorb करने लगते हैं. Okay, so as we already study, so because of that one, because of the adsorption, the substance which is showing the affinity, okay, जिन जो कि adsorption होने चाहते हैं, जिनके पास वो attraction power है, जो कि adsorb की तरफ खींचे चले जाते हैं, उनके वजह से क्या होता है, व्हाट एवर द स्पीड्स आर देयर, जो यहाँ से ऐसे नीचे जाने वाली जो स्पीड रहती है, ओके, इनिशियली दे आर एज पर द स्पीड्स. इफ हमने यहाँ पे अगर सब्सटेंस ऐड किया है तो इनकी इक्वल स्पीड है. दैट स्पीड इज नथिंग बट, आपके पास अगर ये आपके पास ये कंपोनेंट है तो इनिशियल में इनका स्पीड सेम ही रहेगा, लेकिन बाद में अगर इसकी एफिनिटी कम है तो जल्दी चला जाएगा, और इसकी एफिनिटी ज़्यादा है तो स्लोली स्लोली जब तक नीचे पहुंचता है तो एक सब्सटेंस यहाँ पे पहुंचेगा. लाइक दिस वन, देयर इज एन एड्सॉर्प्शन, मीन्स व्हाट द कंपोनेंट्स आर एड्सॉर्ब टूवर्ड्स द एड्सॉर्बेंट, और जैसे उनकी तरफ एड्सॉर्ब होने लगते हैं तो उनकी स्पीड, ओके, टूवर्ड द स्टेशनरी फेज, सो हैविंग लेसर एफिनिटी टूवर्ड द स्टेशनरी फेज, ट्रैवल फास्टर. तो ये क्या होती है, जल्दी से ट्रैवल होने लगते हैं. Why they are traveling with the faster speed? Because they are doesn't showing any kind of affinity towards the whatever the stationary phase are there. But the component which are having the more affinities, which are having the more affinity, they are travel slowly, क्योंकि वो स्लो होने लगते हैं, क्योंकि वो एब्जॉर्ब होने लगते हैं. एंड हेंस द कंपोनेंट्स गेट सेपरेट ऑन द बेसिस ऑफ द एफिनिटी। और उसके बेसिस पे क्या होता है, कंपोनेंट गेट सेपरेटेड आउट एंड वी डन विद द एनालिसिस। सो इसके ऊपर हम क्या बोलते हैं, द कंपोनेंट्स आर गेट सेपरेटेड, okay, on the basis of its affinity. So that is the simple principle on the basis of gas solid chromatography. ये जो principle है ये gas solid chromatography का है, okay. So we have to study about the uh, gas liquid chromatography now, and on the basis of this one अगर हम इसके ऊपर अगर हम लेंगे, okay, so the mixture of component to be separate converted, सबसे पहले अब हमने पार्टीशन लो या एड्जॉर्प्शन लो, तो सब्सटेंस अगर हम लेने वाले हैं वो सब्सटेंस सबसे पहले कन्वर्टेड इनटू द वेपर फॉर्म्स, ओके, द मिक्सचर ऑफ कंपोनेंट टू बी सेपरेटेड, इट गेट कन्वर्टेड और कन्वर्टेड इनटू द वेपर फॉर्म्स एंड मिक्स विद द गैसियस मोबाइल फेज। हम क्या करेंगे फिर उसको गैसियस मोबाइल फेज के साथ मिक्स करेंगे, ओके। सो द कंपोनेंट विच इज मोर सॉल्युबल, अब ये क्या होगा, अब इसमें तो एफिनिटी नहीं है, अब ये जो है हमारे पास एक कॉलम है और व्हाट आर द थिंग्स आर देयर वेयर सेपरेशन है, हमारे पास एक पेपर है, पेपर के ऊपर हमने क्या किया है कि यहाँ पे एक सैंपल पुटअप किया है, यहाँ पे एक सैंपल पुटअप किया है, यहाँ पे एक सैंपल पुटअप किया है, तो क्या होता है कंपोनेंट विच इज मोर सॉल्युबल। अब यहाँ से हमने गैस पास कर रहे हैं, यहाँ पे आपका एक सैंपल है, यहाँ पे आपका एक सैंपल है, तो अब क्या होगा कि ये जो सैंपल विच इज इन द फॉर्म ऑफ वेपर, ये जो है ना वेपर फॉर्म में है, तो ये क्या होगा कि ये वेपर जो है वेपर फॉर्म का जो सैंपल है दैट गेट मिक्स with your mobile phase, that is gas, and uh, they get solubilized. Some of the compounds they get solubilized and they get travels faster. Sorry, they when they are get solubilized, they travel slower and elute later. अब इसके बीच में क्या होने वाला है कि ये जो है ना, अब यहाँ पे adsorption नहीं होने वाला है. It is called as a partition kind of chromatography. Partition means what? Reason partition coefficient takes place. One travel with the faster speed, one travels with the slower speed, which is soluble into that mobile phase. They are reduced with their speeds. जो soluble होते हैं वो reduce होते हैं उनकी speed, और जो insoluble रहते हैं they travel with the faster speeds. Okay, वहीं पे compounds which are more soluble in stationary phase travels slower and elute later. वो elute later होते हैं. And the component which is less soluble, जो कि क्या है, उनकी solubility कम है, they get eluted out first. वो क्या होता है, elute out first होते हैं वो. So अब ये तो पता ही है कि अब दो कंपोनेंट, no two component has same partition coefficient. दोनों कंपाउंड की कभी भी सेम पार्टीशन कोएफिशिएंट कभी भी नहीं रहेगी. ओके, सो कंपोनेंट सेपरेट अकॉर्डिंग टू देयर पार्टीशन कोएफिशिएंट. ओके, कंपोनेंट का सेपरेशन किसके ऊपर पे होता है, उनके पार्टीशन कोएफिशिएंट पे. एंड व्हाट इज द पार्टीशन कोएफिशिएंट? इज द रेशियो ऑफ द सोल्युबिलिटी, ratio of the solubility of the substance distributed between the two immiscible liquids at a constant temperature. So the solubility indirectly comes very important factors. Okay, so ratio of the solubility of the substance distributed between the two immiscible liquids at constant temperature. That is called as the partition coefficient. उसको हम बोलते हैं partition coefficient. So solubility के हिसाब से हम उसका separation करने लगते हैं और उसके ऊपर ये solubility substance get out the separate. That is a partition kind of chromatography. इसे हम बोलते हैं partition type of chromatography. I think you are getting with the adsorption type of chromatography as well as the partition type of chromatography. Okay, so now move toward the instrumentation part. So in the case of this instrumentation, if you able to see, here is a carrier gas chamber, or it like similar like a tank in our home where we store the gas. Like this one gas tank is there. So here we suppose आपके पास जो घर के अंदर टाकी रहती है वो इसके के हिसाब से सपोज, और उसके अंदर हमने क्या किया, we have stored the carrier gas. Okay, so इसके अंदर हमने पूरा carrier gas put up किया. And here is what, the gas flow regulator. जैसे हम अपने घर के गैस का ये करते हैं, इस्तेमाल करते हैं, हम क्या करते हैं, जब हमारी ज़रूरत होती है गैस की तो हम उसको ऑन कर लेते हैं, उस नॉब को ऐसे मूव करते हैं क्लॉकवाइज एंटी क्लॉकवाइज, तो क्या होता है उसकी वजह से गैस यहाँ से यहाँ पे ऐसे ट्रैवल होने लगती है, और अगर नहीं होता तो गैस इट कैन बी ट्रैवल फ्रॉम दिस पॉइंट टू दियर. सो दैट इज द रोल ऑफ गैस फ्लो रेगुलेटर. ओके, सो एज पर just not only to pass the gas as per the speed, as per the velocity that we have to travel the gas, that can be maintained by gas flow regulator. ये regulator regulate करने का काम कौन करेगा? Gas flow regulator. Then here is what, there is an इंजेक्शन पोर्ट. इंजेक्शन पोर्ट से हम क्या करेंगे? ऐसे सैंपल इसके अंदर पुट अप करेंगे, एंड हियर फ्रॉम दिस डायरेक्शन देयर इज एन, व्हाट इज कमिंग, द व्हाट एवर द कैरियर गैस इज देयर, सो दैट कैरियर गैस कम फ्रॉम दिस साइड, एंड हियर इज व्हाट, हियर इज एन कॉलम, इसको हम बोलते हैं कॉलम, और यहाँ पे क्या है? देयर इज एन ओवन. व्हाट इज द रोल ऑफ ओवन? टू प्रोड्यूस अ पर्टिकुलर टेम्परेचर. सो टेम्परेचर प्रोवाइड करने का काम ये ओवन करेगा. ओके, सो here is what, through this injection port the sample is introduced in the case of this one. Okay, और यहाँ पे फिर इसका जो ये रिमेनिंग पॉइंट है, यहाँ पे हम स्टडी करेंगे how there is a conversion of the sample takes place. Conversion means what? Conversion into the solid, into the vapors form, solid liquid, उनको हम वेपर फॉर्म में कन्वर्ट करेंगे, और फिर यहाँ से नीचे आएंगे, यहाँ से आपके कैरियर गैस में मिक्स हो गए, और थ्रू दिस दे ट्रैवल्स विद दिस व्हाट एवर द कॉलम्स आर देयर. अब इसके अंदर क्या रहेगा? एडजॉर्बेंट रहेगा. सो इफ इट इज एन पार्टीशन और इफ इट इज एन व्हाट एवर द टेक्निक्स आर देयर, मोस्टली अब एडजॉर्बेंट माइट बी कोटिंग विद द लिक्विड्स, तो लिक्विड होगी तो पार्टीशन के बेस पे होगी, और अगर यहाँ पे पूरा सॉलिड होगा तो क्या होगा? एडजॉर्प्शन के बेस पे होगा, और यहाँ पे जाके फिर सेपरेशन होगा कंपोनेंट का, एंड देन separate component get toward detector, and detector towards here is the waste, sample जो waste हो गए, and that detector gives out the signals. detector हमें क्या करेगा? signals देगा, and that we computer and data analysis, हमें ग्राफ मिलेगा और उसके ऊपर हम क्या करेंगे? analysis करेंगे. so that is the basic, what are the things that we have to be study in the case of instrumentation. ये पूरी चीजें हम इस instrumentation में study करेंगे. means what are the components are there? Carrier gas, then there is an flow regulator, that is a part of the carrier gas, then sample injecting systems, second component, third is your column, and fourth one is your detector, then column thermostat is the fifth, and the sixth one is your readout and device. So whole parts comes under this instrumentation. So ये पूरी चीज़ हम instrumentation. तो हम आज के लेक्चर में through this column, ये ओवन वगैरह जो डिटेक्टर है, that part we study next. Till this point we study in today's lecture. Okay, so as I told you, components. Okay, so whatever the components are there, that carrier gas, so maintain at higher pressure, then the sample injecting systems, separation column, various kinds of detector, thermostat chamber, amplifier and recording. These are the 6 points that we have to be study in today's lecture. Okay, so we study about, so carrier gas. Whenever we study about the carrier gas, what kind of requirements is there for the carrier gas, that must be studied. So carrier gas, it should be inert. हम जो भी करने carrier gas study करने वाले हैं, it should be inert. Okay, inert होनी चाहिए. Readily available in higher purity. It must be. Purity is very important. So readily available in high purity. It should be cheap. हमें सस्ती means it can be costlier one. It should be cheaper in nature. और cheaper होनी चाहिए. जैसे air है, hydrogen है, helium है. These are the kind of things that which are cheaper. Should not cause risk of fire. Very important point that we are saying that it should not cause risk of fire. जब हम इसका यूज करेंगे तो इन्होंने कभी भी फायर, रिस्क ऑफ फायर नहीं होना चाहिए. एंड इट गिव्स द बेस्ट कॉलम परफॉर्मेंस. ये हमें क्या करना चाहिए? इसने बेस्ट कॉलम परफॉर्मेंस इसने देना चाहिए. एंड इट शुड हैव अ हायर डेंसिटी. इनकी डेंसिटी क्या होनी चाहिए? दे मस्ट बी रिक्वायर डेंस वन, सो हायर डेंसिटी वी रिक्वायर. ओके, सो दिस इज ऑल अबाउट द requirements: inert, purity, cheap, no risk of fire, best column performance, and higher density. These are the requirement of carrier gas. So as per the requirement, so what we are studying means we are requiring the carrier gas. So that gas is classify it into 4 types that we are requiring: hydrogen, helium, नाइट्रोजन, एयर. हना एज आई मैंने शॉर्ट में इसका नाम दिया है HHNA है ना, okay, HANA नहीं है, HHNA है ना, okay. So hydrogen, helium, nitrogen, air. So keep it in your mind, these are the four types of the carrier gas. So start with the hydrogen. हम क्या करेंगे, पहले हाइड्रोजन के ऊपर यूज करेंगे. सो हाइड्रोजन, सो इट इज मोर एडवांटेजेस एज कम्पेयर टू द अदर गैस. अब ये सब बाकी के गैस से अच्छा है क्योंकि it is cheaper one, easily available, but it is a more advantageous as compared to other gas, but it is dangerous to use. Problem क्या है, it is dangerous to use, but it has better thermal conductivity. It can be used, means it has a better thermal conductivity and also have lower density. Okay, but having the lower density, we require a higher density, but it is having a lower density. Requirement, as I told you, most important requirement is it is a cheap. बहुत cheap है, लेकिन इसका ड्रॉबैक भी उतना ही बड़ा है. हाइड्रोजन बहुत रेयरली यूज कर रहे हैं. ओके, it has disadvantage that may react with unsaturated compound. ये क्या होता है, unsaturated compound के साथ react होता है and they may create fire और explosive hazard. वो क्या करते हैं, एक तो फायर कॉज कर सकते हैं और दे में convert into the explosive hazard. But when they react with an unsaturated compound, जब unsaturated compound के साथ अगर वो react होने लगेंगे तब जाके ये प्रॉब्लम हो सकता है. So that is about the hydrogen. Then the second one is the helium. Helium is the second preferable type of carrier gas. It is, the drawback is that it is an expensive. Remaining one is a cheap, but it is an expensive. It shows the excellent thermal conductivity. Okay, that inertness. Okay, conductive inertness, low density, and allow greater flow rate. The very important thing, it allows the greater flow rate. The flow rate is higher in the case of this one, means it can easily carrier gas jaldi se travel होने लगती है. So that is about the helium. Third one is the nitrogen. So nitrogen, it is an inexpensive gas. Nitrogen क्या है? It is also inexpensive gas, very inert, will not react with the analytes and give very time efficient separation, non-flammable. Mostly we are using the nitrogen. Okay, why? Because simplest one, it is inexpensive, means expensive is less expensive. Then second thing is very inert, ये inert है, will not react with analytes, analyte के साथ react नहीं होता है. Then gives very time efficient separation, हमें क्या करता है, time efficient separation भी हमें देता है. Then non flammable, so flame का कोई danger नहीं है. Disadvantage is low velocity, narrow range for maximum efficiency. Okay, so इसकी low velocity and for narrow range for maximum efficiency. That is a smaller drawbacks. Remaining is a good one. So that's why this is an nitrogen is the another preferable type of carrier gas. And finally air, but air is very rarely we are using that one. So although we know that एयर कैसी है, बहुत सस्ती, इजीली अवेलेबल है, हम उसको फिल्टर करके भी यूज़ कर सकते हैं, लेकिन एयर हम यूज़ कब करते हैं, यूज़ ओनली इफ ऑक्सीजन प्रेजेंट इन इट. अगर सैंपल के अंदर ऑक्सीजन अगर प्रेजेंट रहेगा तभी हम एयर का यूज़ करते हैं. सो दैट इज द थिंग, these are the four types of the whatever the carrier gas are there. So move toward the next one. Okay, but requirement, there is a chart is there, so we study about that chart. So other point are there, that how much is the pressure that we are required for the carrier gas. So pressure range for carrier gas is 10 to 50 psi. हमें कम से कम क्या होनी चाहिए, 10 से 50 psi की प्रेशर होनी चाहिए. Then higher pressure increase the compression possibilities. अगर हाई प्रेशर रहेगा तो क्या करेगा, that increase the compression possibility, and लो प्रेशर रिजल्ट इन लार्ज बॉन्ड बर्निंग. हमें क्या चाहिए, हाई अगर बहुत ही ज़्यादा प्रेशर हो गया तो क्या हो गया कि कॉम्प्रेशन पॉसिबिलिटीज हो गई. ओके, एंड लो प्रेशर रिजल्ट इन लार्ज बॉन्ड बर्निंग. तो हमें लार्ज साइज कैसे क्या मिलेंगे, वी गेट इट एंड लार्ज साइज ऐसे पिक्स मिलेंगे. सो लाइक दिस वन, व्हाट वी रिक्वायर लाइक दिस वन, प्लेन हमें ऐसे ग्राफ चाहिए, बट इट कैन गेट लाइक दिस वन. So that is a band bonding, large band bonding. For column dimension, flow rate range from 50 to 150 ml per minute. तो इतने इसके हिसाब से means for column dimension, flow rate range from. So there are the various kinds of column that we are using. So there is a different flow rates are there. There are the different flow rates. So range from 5 to 150 ml per minute. And for analytical column, flow rate is 20 to 50 ml per minute. And for the capillary columns, flow rate is 1 to 5 ml per minute. Why there is a difference between this one? Because there is an internal diameter. Here is an analytical columns and here is an capillary column. So these are very thin, so internal diameter is very small. So require is very small amount of the solvents or the very small amount of the gas. But in the case of analytical column, it is the larger one, pack columns are there, where the internal diameter is large, so it can be added the 20 to 50 ml per minute. Okay, flow rate is there. Okay, so there are the various parameters like safety. Helium is safe, hydrogen is the cautious, nitrogen is safe. Okay, so helium we have to store in the cylinder. Hydrogen can keep it in a cylinder or generator, and it can be say keep it in the cylinder or generator. So we can generate that nitrogen. Okay, most of the, as I told you, nitrogen is the industry. Whenever we enter into the industry, whenever we see any kind of gas chromatography, generally nitrogen is kind of gas that we are using. Okay, it is an expensive. Helium is expensive. एक तो उसके ड्रॉबैक भी बहुत ज़्यादा है और एक्सपेंसिव भी है. It is cost effective. It is cost effective. Okay. Supply. Whenever we can study about the supply concern, okay, so it can be concern क्योंकि हमें उसको चेक करना पड़ेगा कि अवेलेबिलिटी है कि नहीं. In the case of hydrogen helium, we are not required to be supply because that can be generated. हम इसको लैब में जनरेट कर सकते हैं. So we are not dependent on the others. हम इसके इसमें दूसरे के ऊपर डिपेंडेंट नहीं है. हम हमारे खुद के लैब में इसको तैयार कर रहे हैं. Column choices. So whenever we are using helium, wide to narrow bores. Okay. हेलियम अगर यूज़ कर रहे हैं तो हेलियम गैस के लिए हमें जो कॉलम्स है दैट वाइड एंड नैरो बोर के चाहिए. हाइड्रोजन के लिए नैरो बोर और नाइट्रोजन के लिए भी नैरो बोर. तो इंटरनल बोर्स आर देयर, दैट इज वी रिक्वायर द नैरो वन. ओके, सो इनर्टनेस दे आर. अब इनर्टनेस में अगर हम स्टडी करेंगे तो हेलियम इज इनर्ट, हाइड्रोजन इज हाईली रिएक्टिव एंड नाइट्रोजन इनर्ट. सो अगर हम ओवरऑल अगर हम इसमें स्टडी करना चाहेंगे तो सेफ, सिलिंड्रिकल जनरेटेड, कॉस्ट इफेक्टिव, नॉट अप्लीकेबल, नैरो बोर और इनर्ट. मैक्सिमम पूरे के पूरे पैरामीटर हमें नाइट्रोजन में मिल रहे हैं. हाइड्रोजन में भी तो रिएक्टिव हो रहा है. यहाँ पे एक्सपेंसिव है, लेकिन ऐसी कोई भी चीज़ नाइट्रोजन के लिए अंदर नहीं है. दैट्स वाई वी आर प्रेफरिंग द नाइट्रोजन. सो I think if you are getting that one, which kind of carrier gas we are preparing in the case of this one. Okay, so move toward the now next slide. That is a flow meter and flow regulator. Okay, जैसे हमारे गैस के अंदर ऐसा रहता है और हमारा अगर सिलेंडर रहेगा तो ऐसा रहेगा. Okay, so hard knob is the regulator or valve, cylindrical valve. ओके, अगर हम इसको ही क्लोज कर लेंगे तो सिलेंडर से गैस ही नहीं आएगा. यहाँ पे भी आ गया, लेकिन अगर हमें ज़रूरत चाहिए तो रेगुलेटर और वाल्व भी हम करेंगे इसको. ठीक है. सो फ्लो रेट और द फ्लो मीटर डिलीवर द गैस विथ यूनिफॉर्म प्रेशर और फ्लो रेट. ये क्या करेगा? डिलीवर द गैस विथ यूनिफॉर्म प्रेशर और फ्लो रेट. सो फ्लो मीटर, दैट इज अ रोटामीटर. ओके, so soap bubbles flow meter. So there are the different types of flow meters there. Deliver the gas with uniform pressure or flow rate. That is important thing for the flow meter. Okay, so rotameter is this. Okay, अगर हम इसमें इस चीज़ में हम रोटामीटर करेंगे तो place before column inlet, it has a glass tube with a float held on the springs. It has a glass tube. इसके अंदर क्या है? Glass tube है with a float held on the springs. So level of the float is determined by the flow rate of carrier gas. So that can explain the carrier gas flow rate. Soap bubble meters. Okay, so downward there is a soap bubble meter. So in the case of similar to rotameter, instead of floats of bubble form indicates flow rate. ये जो bubble form करके क्या करेगा, indicate करेगा कि how the flow rate is there. So that is the flow regulator. Okay. Then the next component is then injecting system or sample introduction. Okay. So while if you able to see in this diagram, here is a syringe through which we passes the sample. Here is a septum. It is a self-sealing silicon rubber septum. Then there is a needle is goes towards here. Here is the entry of the carrier gas. Here is a vaporization chamber where vaporization takes place, and then towards the column. So same thing over here. Use small amount of sample. So whatever the sample that we are require, that sample must be of smaller quantities. Amount उसकी कम होनी चाहिए. Sample reduction in reproducible manner. हम sample reduction reproducible manner में हम उसको कर सकते हैं. And should vaporize it instantly. ये क्या होगा? यहाँ पे वेपोराइजेशन चैम्बर के अंदर क्या हो जाएगा, इसका वेपोराइजेशन हो जाएगा. सैंपल इंट्रोडक्शन reproducible manner and should vaporize it instantaneously so that sample will enter the column as a slug. Okay, so liquid sample introduced by hypodermic syringe. Liquid sample रहेगा तो उसको हम क्या करेंगे, hypodermic syringe के साथ ऐड करेंगे. So they are composed of glass tube. ये जो बनी है ट्यूब, that is made up of an glass tube. Okay, so septum type of an injection. हमारे पास क्या है कि that septum type of an injection are generally used. हम इसके अंदर क्या करेंगे, septum. So this one is a septum. As I told you, it is a self-sealing silicon rubber septum. Okay, so self-sealing means what? हम जैसे सैंपल ऐड करेंगे ना, सैंपल ऐड करने की वजह से अब इसके अंदर सेप्टम के ऊपर से वो पास होगा तो इट कैन बी डिस्टर्ब टू दिस वन, बट दिस इज सेल्फ सीलिंग, तो इट सेल्फ इट गेट सील. जैसे हम इंजेक्शन ऐड करेंगे तो इट सेल्फ सील होता है. सो ओके, सो सैंपल इंट्रोडक्शन इंजेक्टेड थ्रू द सेल्फ सीलिंग सिलिकॉन रबर सेप्टम हमने ऑलरेडी डिस्कस किया. आफ्टर इंट्रोडक्शन ऑफ सैंपल इट इज हीटेड एट अ फिक्स्ड टेम्परेचर. हमने यहाँ से अब सैंपल यहाँ पे आ गया, तो यहाँ पे आने के बाद क्या करेंगे, there is an vaporization chamber or where there is heating start. It is heated at a fixed temperature till it convert into vapors. हम क्या करेंगे, इसको हीट करेंगे. हीट कब तक करेंगे, जब तक ये वेपर में कन्वर्ट नहीं होंगे तब तक हम क्या करेंगे, इसको हीट करेंगे. ओके, सो आफ्टर दैट into the valve. So after this converted into vapors, vapor is introduced into carrier gas stream by means of valve. So यहाँ से क्या करेंगे, कैरियर गैस के साथ मिक्स हो गए. ओके, सो सॉलिड सैंपल, अगर आपके पास सैंपल अब लिक्विड है, लेकिन अगर आपके पास लिक्विड की जगह सॉलिड है तो सॉलिड सैंपल मस्ट बी डिजोल्व इन वोलेटाइल सॉल्वेंट. अगर आपके पास सॉलिड सैंपल स्टडी करना है तो हमें क्या करना पड़ेगा, सॉलिड सैंपल मस्ट बी डिजोल्व इन वोलेटाइल सॉलिड्स. हमें क्या करना पड़ेगा, वोलेटाइल सॉलिड के अंदर इसको डिजोल्व करना पड़ेगा. और मे बी इंट्रोड्यूस डायरेक्टली. हम क्या कर सकते हैं, उसको डायरेक्टली इंट्रोड्यूस्ड कर सकते हैं इफ नॉट लिक्विडिफाइड. ओके, अगर ये लिक्विडिफाइड नहीं किया और मे बी नॉट बी इंट्रोड्यूस्ड डायरेक्टली इफ नॉट लिक्विडिफाइड. ओके, सो लिक्विडिफाइड हम कैसे करेंगे, इन व्हेनेवर इट इज इन वोलेटाइल सॉल्वेंट्स. ओके, सो require special water for introduction into the carrier gas streams. So what we require, a special carrier gas we require for introduction into the carrier gas stream. हमें अगर इसको carrier gas में introduce करना है तो हमें special valve लगेगी. Okay, so next component is the column of gas chromatography. Okay, so अब जैसे वहाँ से आ गया, means it reached from this one, हमने inject तो कर लिया sample. Injection के बाद एक sample कहाँ पे चला जाएगा, that is in the vapor form is reached toward the column. अब column is nothing but the column are the heart of chromatographic technique. Column क्या रहते हैं, chromatographic technique. Okay, so whatever the usually made up of glass or metals, ये क्या रहते हैं, that made up of, column कैसे made up होते हैं, made up of glass और metal. ये एक तो glass से बनते हैं या metal से. Okay, metal such as stainless steel. अगर हम इसमें metal भी लेंगे तो metal का भी example रहेगा stainless steel. So stainless steel have long life. स्टेनलेस स्टील का क्या है, लॉन्ग लाइफ, एंड कैन बी हैंडल इजीली. हम इसको इजीली हैंडल कर सकते हैं, बट दे रिएक्ट विथ सम कंपाउंड्स. ये क्या होता है, दे कैन रिएक्ट विथ सम कंपाउंड्स. ओके, सो ग्लास कॉलम्स आर वाइडली यूज्ड एज दे आर इनर्ट. लेकिन अगर हमें इनर्ट ही चाहिए कॉलम, तो हम क्या करेंगे, दैट मेड अप ऑफ अ ग्लास. ओके, सो कॉलम कैन बी यूज्ड फॉर प्रिपरेटिव एंड एनालिटिकल पर्पस. कॉलम का हम तो प्रिपरेटिव के लिए यूज कर सकते हैं और एनालिटिकल पर्पस के लिए भी यूज कर सकते हैं. ओके, सो टाइप ऑफ कॉलम्स. So that might be a packed column, open tubular column, support coated open tubular column. So different kinds of the columns are there that we are using. Packed columns, open tubular columns, support coated open tubular column. These are the three different types of columns that we are using in the case of this one. Okay, so start with the packed columns. So GSC, that is a gas solid chromatograph packed with the granular adsorbent porous polymers. अगर आपके पास क्या है, गैस सॉलिड क्रोमेटोग्राफी है, तो हमने इसके अंदर अगर हमने सैंपल पुटअप किया है तो गैस सॉलिड पैक विद granular adsorbent or porous polymers. And if you want to study the gas liquid chromatography, that gas liquid chromatography with the pack with the liquid phase coated with inert solid supports. हम क्या करेंगे इसको inert solid support के साथ इसको we are keeping to this one. So GLC pack with the liquid phase coated over the inert solid support. So these columns are fabricated from the glass. So generally or stainless steel or copper or other suitable tubes. If you're able to see, stainless steel is most preferable in the case of this one. Okay. So अगर आप ये जो कॉलम है यहाँ से एंट्री क्या हो रही है आपकी जो गैस हो रही है सैंपल साथ, और यहाँ से फिर ऐसे ऐसे राउंड होके फिर इसके अंदर क्या एडजॉर्बेंट है और देन इट गो टू अर्थ. सो अब अगर आप पैक कॉलम, द नेम इज इंडिकेट पैक कॉलम्स, तो इसके अंदर अगर हमने कॉलम अगर हमने देखा है तो इसके अंदर ऐसे इंटरनल जो है ना ये एडजॉर्बेंट है उसके अंदर पैक करके रखे हमने, दैट इज क्या पैक कॉलम्स आर देयर. ओके, अगर इसके अंदर लिक्विड का गैस लिक्विड होगा तो इसके ऊपर क्या होगा, लिक्विड फेस कोटेड ओवर द इनर्ट सॉलिड सपोर्ट्स, इसके ऊपर हम लिक्विड कोट रहेंगे और सॉलिड रहेगा तो इसी दिस आर द सॉलिड्स आर देयर. ओके, so as I told you, stainless steel is the most common tubing used in the internal diameter. So internal diameter 1 to 4 mm. 1 to 4 mm means what? 1 mm means what? 0.1 centimeter. So 0.1 to 0.4 centimeter is the internal diameter that we are using in the case of this one. Okay, so the column is packed with the final divide particles. हम क्या करेंगे? This column is packed with the finally divide particles that is greater than the 100. Okay, 100 to 330 micrometer diameter is there. Okay, which is coated with the stationary phase. Okay, so however glass tubes are also used for large scale preparation. अगर हमें उसमें से भी अगर ज़्यादा प्रिपरेशन करना है, ज़्यादा सेपरेशन करना है, ज़्यादा अमाउंट में करना है, तो हम क्या करेंगे, इंस्टेड ऑफ यूजिंग द स्टेनलेस स्टील वी आर रिप्लेसिंग इट विद द ग्लास. हम क्या करेंगे, इसको ग्लास से रिप्लेस कर लेंगे. ओके, सो these are the things that is used in the case of pack columns. They are the polymer that we are using. They are the various kinds of advantages of the polymers. No bleed of the columns and polymer stable for 250 degrees Celsius. 250 डिग्री सेल्सियस तक भी ये स्टेबल होते हैं and cause no baseline drift. It doesn't cause any kind of baseline drift. There is no adsorption of polar compounds such as water, alcohol. Okay, so there is no adsorption of polar compounds like water, alcohol, acids, and they elute rapidly as sharp symmetrical peaks. ये भी क्या होते हैं, तो adsorption नहीं होता है उनका, और secondly क्या हो जाते हैं, that eluted rapidly as a sharp symmetrical peaks. हमें जल्दी से symmetrical peak मिलती है. Sample overload recovery is rapid. इसके अंदर क्या होता है कि अगर हमने सैंपल ऐड किया है तो ओवरलोड रिकवरी इज रैपिड and quite useful in preparation and trace analysis work. It quite useful in preparation. ये preparation के लिए quite useful है and trace analysis. हम इसमें trace analysis भी बहुत जल्दी कर सकते हैं. Porous polymers beds are mechanically strong. ये तो एक सबसे बढ़िया चीज ये है कि ये mechanically strong है and can be packed as a columns. हम क्या कर सकते हैं, उसको pack as a column कर सकते हैं. And separation is unique. हम एक unique separation मिलेगा और retention data highly reproducible. We can get the reproducible means we can multiple time अगर हम उसको sampling करेंगे तो वैसे के वैसा ही result हमें मिलेगा. So that is the pack columns. Okay. Second type is the, what is the second type is the open tubular columns. Okay. So it also refers as the open means what, internal. अब ये जो पूरे pack नहीं है, that is the open tubular columns. Also refers as a column, capillary columns, which is very thin. One thing is remember that one. It is very thin. Okay, that's why it refers as a capillary. Capillary के जैसे बहुत thin है, and also called as the Golgi columns. हम उसको separately second नाम उसको देंगे, Golgi column भी हम उसको बोलते हैं. So they are made up of long capillary tubing. ये क्या होते हैं? They are made up of long capillary tubing that is 30 to 90 meters. that is meter, I'm not saying centimeter. So they are rising from tubing from 30 to 90 meters. If you're able to see, here is a small, अब ये जो internal diameter देखो, okay, so very thin रहते हैं, and they are made up of long capillary tubing that is 30 to 90 meters. तो इतनी बड़ी size की होती है, length is very large, 30 to 90 meters, and internal diameter is what, 0.025 to 0.075 centimeter, means what, uh, it is 0.0025 मिलीमीटर से लेके 0.0075 मिलीमीटर तक, ओके, और 25 10⁻³ मिलीमीटर से लेके 75 10⁻³ millimeters तक, okay, that is an internal diameter is there, and which is made up of a stainless steel, copper, nylon और glass, okay, ये तो एक copper से बन सकता, stainless steel, nylon और glass, they can be made out of anything, okay, stainless steel also here is also favored one, okay, so inside wall of the capillary tubing is coated with a stationary phase. अब इतने thin के अंदर inside this one the capillary tubing is coated with a stationary phase that is 0.5 to 1 micron. अब ये बहुत ही छोटी है, 0.5 to 1 micron, in the form of thin uniform film, in the form of thin uniform film, and due to the open tubular carries gas can easily flow, okay, because of it is an open tubular carries gas can easily flow, but more sample can not load. ड्रॉबैक क्या है, मोर सैंपल इसमें लगेगा नहीं, कम, लेकिन एडवांटेजेस भी बोल सकते हैं हम कि हमें कम गैस लगेगी इसके अंदर क्योंकि इसकी डायमीटर ही बहुत कम है, और सेकंड थिंग क्या है, ये तो ओपन ट्यूबुलर कॉलम है, तो इसमें से फ्लो बहुत जल्दी होगा, इट कैन इजीली फ्लो, द गैस कैन इजीली फ्लो टू दिस वन ओपन ट्यूबुलर कॉलम एंड वी कैन सेपरेट इट आउट. So that is about the second thing, that is open tubular column. Although supported open tubular column, that is a part of open tubular columns. Okay, so that different points are there. So move toward the third point. I think you are getting with the open tubular columns. Okay, now we go toward the supported open tubular column. So these are mainly of two types. इसके क्या है, दो types है. Wall coated open tubular, WCOT. Okay, so remember this word. Okay, wall coated open tubular columns, okay, so that is 1 millimeter thick, means 0.1 centimeter thick liquid coating on inside of the silica tube, okay, inside of the silica tube, okay, so that is wall coated open tubular column, WCOT, and as that name is the support coated open tubular columns. So support coated open tubular, okay, SCOT, and wall coated open tubular, that is WCOT. Okay, so this one is the 30 millimeter. Support coated is somewhat larger. I am saying 30 millimeter है यहाँ तक के. Okay, so this 30 millimeter thick coating of liquid coated supports on inside of the silica tube. ये जो inside है silica tube के अंदर. So they are used for fast and efficient separation, but are good only for small samples. Okay, अब ये देखो support particles. Okay, so there is a 30 micrometer is there. I am saying it's a millimeter, but it's a micrometer, and here is an 1 micrometer. Correction यहाँ पे है कि यहाँ पे 1 micrometer है और यहाँ पे क्या है 30 micrometer है. Okay, so that is thickness is there, 1 micrometer thick liquid coated on inside of the silica tube. Inside of the silica tube हमने इसमें put up किया है और यहाँ पे भी हमने that is an coating of the liquid coating supported onto the inside silica tube. So इसके ऊपर liquid coating हमने की है, यहाँ पे किया है और इसके ऊपर क्या है liquid coating किया है. Okay, so that thing, so these are used for fast and efficient, as I told you, fast और efficient separation हम इसका use करते हैं. Okay, but for smaller samples are there. So most frequently column nowadays it is a fused silica. हम इसको बोलते हैं FSOT nowadays. It is also called as the fused silica open tubular column. Okay, हम दूसरा नाम क्या बोलते हैं उसको? Nowadays referred as a fused silica open tubular column, FSOT, which is an WCOT, wall coated open tubular column. Okay, so the external surface of the fused silica column is coated with the polyimide film. उसके ऊपर हमने क्या किया है, polyimide film से उसको कोट किया है. टू इंक्रीज द स्ट्रेंथ. इनकी स्ट्रेंथ बढ़ाने के लिए हमने क्या किया है, दे आर coated with the polyimide films. Okay, so these are most frequently used internal diameter occurs in the range of 260 to 320 microns. Okay, so micrometer we are saying. So coating a thin film of liquid phase, हम क्या करते हैं इसको, coating a thin film of liquid phase offer least resistance to flow of carrier gas. ये सबसे important thing क्या है, offer least resistance. इसमें resistance बहुत कम होता है, least resistance to flow of carrier gas, and column prefers for the trace analysis. And this kind of column is preferred for the trace analysis. हम इसका use trace analysis के लिए भी करते हैं. Okay, so there is a chart is there. Okay, so if we suppose internal diameter is 0.1 to 0.53 millimeters. Okay, wall outer wall of the columns and stationary phase is 0.1 to 5 micron meter thick. And internal diameter अगर हम देखेंगे तो 0.1 to 0.53 means 0.01 centimeter ये पूरी इसकी diameter है. So very thin is there, 0.01 to 0.05 centimeter is the internal diameter. तो इतने इसके अंदर फिर हमने 0.1 to 0.5 micrometer thick हमने stationary phase put up किया है. Okay, so first one is the fused silica. Okay, first type of and there is a wall coated open tubular columns, fused silica open tubular columns, support coated open tubular column, and there is a pack columns. So there are different kinds of the column that were mostly there are 4 types of the columns. So length, fused silica that is 10 to 100, wall coated 10 to 100, support coated open tubular 10 to 100, and packed 1 to 6. Okay, might be in the meters, and here is might be in the centimeters. Okay, so internal diameter in millimeter. So internal diameter for the fuse, okay, FSOT, that is a fused silica open tubular, that is 0.1 to 0.53. Then in the case of wall coated open tubular column, that is somewhat large. It is 0.25 to 0.75. Support open tubular column, that is from 0.5, which is somewhat large. And in the case of pack, it is 2 to 4. Okay, so efficiency the plates. Okay, that plates range from 2,400 or 4,000. That is larger. In the case of wall coated open tubular column, 1,000 to 4,000. And support open tubular columns, it might be ranges from 600 to 1,200. And pack columns, very less efficiency of the plates, that ranges from 500 to 1,000. So total plates are there. Okay, total plate कितनी है, 200 to 400 into 10 raised to 3. Okay, in the case of this one, 10 to 400, 10 raised to 3. This one 6 to 120 into 10 raised to 3 multiplied by 10 raised to 3 is there. So we get the 600. Okay, 6,000 to 1,20,000. Here is a 20,000 to 4 lakhs. Here is a 10,000 to 4 lakhs. Here is what, 6,000 to 12,000. Here is a 1 lakh to 10,000. These are the total plates. Sample size ranges from 10 to 75 in the case of FSOT. In the case of so very small amount of sample, here is a 10 to 1,000. Here is 10 to 1,000, and here is 10 to 10 raised to 6. So sample load is higher in the case of relative back pressure is very low. But in the case of pack column, is high. Speed is fast in the case of this one, but pack column it is slow because they are the pack. Chemical inertness, they are the best one FSOT, but they are poor. Chemical inertness is low. Flexible, they are the S, they are flexible. They are not flexible, no, and pack column also not flexible, so they can't be moved. So that is the different charts of the various things of the columns that we are using. Okay. Then there is a capillary columns advantages compared to the pack columns. So we have to study about whatever the advantages are there. They are high resolutions. Okay, capillary column के advantages compared to pack columns. High resolution. अभी हमने स्टडी किया था शॉर्ट एनालिसिस टाइम, ग्रेटर सेंसिटिविटी. ओके, जो हमने यहाँ पे स्टडी किया है. अभी पैक कॉलम्स और यहाँ पे, so they are the speed is fast, then somewhat flexible, then that is things. So inertness is the best, and in the case of there, they are the poorer. So that thing is there. higher resolution, short analysis time, and greater sensitivity compared to the pack columns. Disadvantage also there if there is advantage. So smaller sample capacity. In the case of 10 to 6 तक वहाँ पे थी, लेकिन यहाँ पे 10 to 1000 is the limit of the samples are there. So need better experience. So we require the better experience. That thing in the case of the advantages and disadvantages of the capillary column over the pack columns. Okay, so in short, we have to study about the what are the solid support materials are there that we are using. So solid support materials should be ideally have the following properties. They must be require a large surface area. Okay, uh, at least 1 meter square per gram. How means it has to good mechanical stability. So they are require large surface area, mechanical stability होने चाहिए. They are must be require thermally stable. Solid होने कैसे चाहिए? Support means the adsorbent are there. Inert surface in the order to simplify retention behaviors and the prevent solid adsorption. Okay, inert surface in order to simplify retention behaviors and prevent solid adsorption. And the particle size in the range from एक तो यूनिफॉर्म होनी चाहिए पार्टिकल साइज दैट नो डाउट बट रेंज फ्रॉम 1000 to 400 millimeters, but there might be a micrometers. Okay, selection of the stationary phase. So generally properties of a good liquid stationary phase are easily to guess where the uh, inertness toward the solute is essential. Okay, selection किसके बेस पे? There must be inert, then there must be very low volatility. Okay, liquid that have a good adsorbent and diffusion solubilities for analytes are required for the sexual separation. तो उनकी volatility क्या होनी चाहिए? Very low होनी चाहिए. So an adsorption factor that influences the performance of the stationary phase, it is thermally stable. It must be thermally stable, where a stationary phase should be thermally stable in order to obtain a reproducible result. ये thermally stable होगा तभी जाके हमें क्या मिलेगा? We get the reproducible results. हमें इसमें reproducible result मिलेगा. Okay, then the non-volatile liquids assures minimum blendings of the stationary phase. Non-volatile liquids assume the minimum blendings of the stationary phase. So percent of the loading, हम loading कितना चाहिए? Weight of the liquid of stationary phase. This one is multiplied by 100% divided by the weight of the stationary phase plus solid supports. That much amount of loading we can done. So increase the percent loading would allow for the increased sample capacity and cover any active sites on the solid supports. तो जैसे हम percent increase करेंगे, leading would allow to increase the sample capacity and cover any active sites on the solid supports. Okay, so here is also not only the solid, might be there we are using the liquids. So in general, the polarity of the stationary phase should match that of the samples constituent. Like the, it can be like the like dissolve like rules. So most stationary phase are based on poly, okay, that is the polydimethyl sulfoxanes or polyethylene glycol PEG, that is the black ones, through which they are the generally stationary phase should be polarity हम किसके बेस पे करते हैं. These are the two examples that we are using in the case of liquid stationary phase. Okay, so I think thank you very much for the whole part. This was somewhat lengthy part. Okay, I hope you are getting with this lecture. In the tomorrow's lecture, we are studying, or the next lecture we are studying about the whatever detector that we are using. There are the various types. In books, they have given the few types, but now in the case of this one, we have to study each and every detector. Okay, so I must say thank you very much. Be safe. Okay, keep learning and wish you a happy learning. Thank you very much once again.